Hello there, it's me, Kweku Watson, and it's Elective ICT. Today's lesson is on system software. My email is kwekuwatson38@gmail.com, and my web is nml.greatsite.net. If you set your goals ridiculously high and it's a failure, you will feel above everyone else's success. If you set your goals ridiculously high and it's a failure, you feel above everyone else's success. James Cameron. I don't think I have to explain this to you, but let me use a scenario to let you understand this. So let's say that you want to get A1 in all your subjects. So you set your goal or your mark for all the subjects to be 90 or 95. You and I know that 95 is A1, 90 is also A1, and then 85 is also A1. So if you set your goal or your mark to be 90 and you don't get 90, but you get 86, 87, you are still getting your A1. So if you set your goal very high and you fail, you're going to feel above everyone else's success. And James Cameron said this. So without wasting much time, you just have to go to lesson objectives. At the end of this lesson, the student should be able to define system software, list the types of system software, explain the types of system software, define list examples, and explain the functions of operating systems. Now, system software. So when we looked at Introduction to Computer Software, I made mention that there are two types of software. One is the system software, and then the second one is application software. Now, system software has everything to do with your computer system or your device. And without a system software, you cannot do anything with your computer. So system software is very important if you want to use a computer or if you want to use your device. Now, system software refers to a collection of programs that manage and control the function of a computer system. It is designed to control the hardware components of a computer and provide a platform for running application software. Now, a collection of programs here means that system software has types. So we don't have one system software doing the whole thing. There are a lot of system software that have come together to manage and control the function of a computer system. It doesn't only manage and control the function of a computer system, it is also designed to control the hardware component inside the computer. And it is also there for application software to run. So without a system software, you can't run an application software. Now, types of system software. So we have one as device drivers, one to be device drivers. Now, anything you do on your computer, so if you attach a mouse or a keyboard or a speaker, anything you attach to your computer needs a driver. Without a driver, whatever you attach to the computer will not be able to function because it can't communicate with the operating system for it to work. So whatever you do, whatever you attach by way of a device, you need a driver for it. So to check your drivers, you have to go to your device manager. This is something that you can quickly do on Google. How to go to your device manager, and then you see all the drivers for applications that you are using or you are running. It's not only devices that you attach to the computer, but components inside the system unit, like your network cards, for instance, and your graphics card. All these things need drivers because they have to communicate. They have to communicate with the operating system, so the operating system will recognize it and then allow it to work. So if you've recognized this, if you attach a new mouse or keyboard to your computer, it tells you that installing device drivers, you should wait. And then once it finishes, it will tell you that device ready to use. If you've ever seen this, yes. And that is also known as a plug and play, where you attach a device to the computer and then you don't have to do anything. The computer itself configures the device for you, and once it's ready, you get to use it. It is known as plug and play. All right, so device drivers. Now, device drivers are software that allows the operating system to communicate with hardware devices, such as printers, keyboards, and then mice. So anything you attach to your computer and some of the components inside your system unit, they need something called drivers to be able to work because the operating system has to recognize the component inside the system unit, and it has to recognize the component or the device you have attached to the computer or the system unit. So it is only when it recognizes it, then it allows you to use it or for it to function. So your touchpad, a lot of things, like I can't list all of them, But device driver or drivers are important, very important, and I'll encourage you to do more Google search on device drivers. Now, programming language translators. Don't forget that we are still looking at types of system software. Now, with programming language translators such as compilers and interpreters, are system software that enable developers to create application software that can run on a computer system. So I believe you know Mavis Beacon, a typing software, a typing tutor, and then your mobile applications like Twitter, Instagram, and the other ones that you have. Yeah, so these applications that you have or these software that you have on your computer and your mobile devices, they didn't come just like that. Okay, you have software developers who wrote codes to get these applications. Now, when you write a code, you write it in a high level. Now, it's high level, so there's low level and then high level. Now, high level programming languages are closer to English, so they are not difficult. However, the computer do not understand our English language or any other language apart from the machine language. So after writing this code, you need to convert the codes to a language that the computer understands for the computer to work on it, and then later it becomes a software that you aimed to get. Now, for the codes that you have written to be able to be translated into the language that the computer understands, you need things like compilers and then interpreters, because these will convert the code, the source codes, to a language the machine understands, which is the machine language, zeros and ones. So for that to be done, compilers and interpreters are needed. And this is where compilers and interpreters are system software, because they communicate with the underlying architecture of the hardware by converting the high-level language to the machine language. So programming language translators are system software. Then you have utility software. Now, utility is a system software that helps to analyze, optimize, manage, maintain, and control the resources of a computer or a computer's resources. Now, for you to efficiently use your computer, you need a utility software. And the utility software comes with a Windows operating system. However, there are third-party utility software that you can download. Now, when you hear third-party software, it means that that software do not come with your computer, so you have to download or purchase it to be able to use it. So with a utility software, it helps us in the smooth running of our computer. So is it a computer with virus is very difficult to use. A computer that runs very slow is very difficult to use. A computer that takes a very long time to boot is very difficult to use. And then all these things can happen to your computer. All these things, your computer being infected with virus, your computer being running slowly, your computer refusing to boot or refusing to shut down or not operating the way you would want it. All these things do happen to our computer. Now, for you to be able to, or for you to have a smooth operation of your computer, utility software are important. Now, to get a utility software or to use a particular utility software depends on the problem at hand. However, when it comes to antiviruses or antivirus, they are utility software that we can't do away with. Whether you have a virus on your computer or not, you need an antivirus to protect you from virus. So antivirus is a utility software. Now, there is a disk cleanup, and disk cleanup is also a utility software. So these are things that we will look at in the next slide. But yes, utility software is also a type of system software. All right, so an antivirus software. So antivirus software is a software that protects users from virus attacks. Now, virus is a malicious software. So if you don't know virus, then it's a malicious software. Now, okay, so with that said, for you to prevent yourself from being attacked by a computer virus or from preventing your computer from being infected with a computer virus, you need an antivirus software to be able to prevent you from getting virus. So Avast is an example of an antivirus. McAfee is an example of antivirus. Kaspersky is an example of antivirus. Norton is also an example of antivirus. And then the Windows operating system also comes with Windows Security, which is also another example of an antivirus. So anything or any software that protects you from virus is an antivirus. All right, so disk cleanup is we browse our computers, we delete files, we move files from one location to the other, and other things. So as we do this, pieces of these files gather, and then we look at the next one, which is defragmentation. So pieces of files gather at places that they are not supposed to, and this causes slowness in our computer system or in the usage of our computer. Now, to be able to or to efficiently have our computer running, we need to do this cleanup. Now, this cleanup comes with a Windows operating system. So all you have to do is to type this cleanup and then you get it from the list of options that are there. Now, so this cleanup will clean files that you do not need on your computer, files that you didn't even know that they existed. It will wipe all of them from there, freeing some RAM space and then hard disk space. The main focus here is hard disk space because as you do all these things you browse on your computer, temporary files, which we call temp files for short, they gather on your computer on the hard disk that you do not even know, eating into hard disk space and then making the time that it takes to get information from the hard disk long. So you need to wipe these things from there so that you free your hard disks and to an extent your RAM. So disk cleanup is very good and it comes with the Windows operating system. It just free your computer's hard disk, that is disk cleanup. Then disk defragmenter. So I made mention that as we delete files, as we copy files, as we move files from different locations, there's files, pieces of these files build up. Now, when you take the hard disk is cylindrical, all right, divided into tracts and sectors where information is stored. Now, information on a hard disk is stored in a contiguous manner or in a contiguous way. So now when you take the hard disk, okay, it has tracts and sectors. So the information are stored in contiguous, like it follows one after the other. So you don't have one information at, let's say, the right side, and then right after the next empty slot that follows, there will be no information there, and then it moves to a different side. No, if you are storing, let's say, a music video or a particular folder that contains files, all the files in that folder will be stored in a contiguous way, meaning that, okay, when it comes to five spaces, these five spaces are for this particular files. So it means that no other file can be saved there. But the problem here is that as we delete, as we move files, as we put files on the hard disk, okay, it moves from its contiguous nature, meaning that files then happen to spread all over the hard disk. So files that are related does not store in that manner again. You have files that are related stored at different locations, and there's a problem because if the files that are related are stored at different locations, if you are accessing the files, the hard disk have to do extra work of putting all these files together, picking them from the different locations and putting them together before you can have the file. Now you don't see this, but it takes a long time to do this, which is not a good thing. So to prevent this, we have to what? Defragment. So defragmentation as a process of rearranging scattered files on a hard disk. So you have to rearrange the scattered files on a hard disk. Once you do that, you have what? Defragment your hard disk. So disk defragmenter helps us to rearrange scattered files on our hard disk. And this disk defragmenter also comes with the Windows operating system. So all you have to do is type disk defragmenter and then it will pop up. Just follow the on-screen instructions and then you will be able to use disk defragmenter. And I encourage you to use disk cleanup and disk defragmenter often so that will prevent slowness or prevent your computer from running very slowly. And these are utility software. Then disk management software. So disk management software has everything to do with how your hard disk is managed. So if you want to partition your hard disk, and this also comes with the Windows operating system, if you want to partition your hard disk, if you want to format your hard disk, if you want to create space for your hard disk, and then those other things. So use the disk management software if you want to manage your hard disk. Now, backup software or backup basically means that copying an original or making a duplicate of an original file or an original data and then saving it from a different location or a different place other than where the original is kept. Now, if you do backup and then you save it at the same location, you can't call it backup, because once you lose the original file, you're losing the backup file. And if you're losing both, then you didn't do backup in the first place. So if you want to term something as backup, then you have to move it to a different location. So when you create or when you copy something or you duplicate something, you have to save it from on a different you have to save it in a different location. So if it is on your computer, you don't save the backup on that same computer. You need to save it on an external hard drive or on a cloud storage. If you do this, then you have done backup. And then, so we have three types of backup. So we have full backup, we have differential backup, and then you have incremental. Now, operating system. Operating system is also a type of system software, but operating system and system software are used interchangeably. Even though they are used interchangeably, I want you to know that when it comes to types of system software, operating system is part, as well as language translators or programming language translators, utility software. All these and device drivers, all these are types of system software. It's just that the operating system has all these things embedded in it. So it's very easy to say that system software is the same as operating system. But just for you to understand how system software works and everything that makes up system software, it is only fair and proper that you break them down so that you can understand them. But if you are looking at it in general, then the operating system can be said to be a system software because it contains all the things that we've discussed. The operating system comes with a device driver. The operating system comes with the language translators. The operating system comes with a utility software. But all these individually are system software. Now, the operating system. The operating system is a system software that acts as an interface between the user and the computer hardware and controls the execution of all kinds of programs on the computer. Now, when it comes to the operating system, it does a lot of work. So it acts as an interface between you, the user, and your computer hardware. Now, without operating system, you'll not be able to launch Mavis Beacon. Without operating system, you'll not be able to type in your password to use your computer. Without operating system, your computer will not even that thing will be on your computer for you to use in the first place. If you're able to use your computer through the operating system, then operating system is acting as an interface for you to be able to use your computer. So it acts as an interface between the user and the computer hardware. And it doesn't only do that, but goes ahead to control all kinds of executions on your computer. So if you launch VLC Media to play a music, the operating system is helping you to do that. If you launch Grand Theft to play game, the operating system is helping you to do that. If you launch a PDF reader to read your notes, the operating system is helping you to do that. So it controls all kinds of programs on your computer, the execution of all kinds of programs on your computer. The operating system does memory management also, it does file management, it handles input and output, the things, the flash drives or pen drives that you slot or insert into your computer, and then the output devices like the speaker and the printer, it handles all that, the way you print, everything that you do. The operating system handles that. And then we have examples of operating systems. Now, there are types of operating system and there are examples of operating systems. Do not mix them up. Now, an example of operating system is Android. Another example is iOS. Another example is Linux or Linux. Another example is Windows. Now, for Android and iOS, they are mobile operating systems. So when you look at desktop operating system, then we have Windows, we have Linux or Linux, we have Ubuntu, we have Kali Linux, we have Oracle Solaris. All these are desktop operating systems. Now, when you look at the mobile operating systems, then we have Harmony, we have Symbian, we have Android, and we have iOS. All these are also examples of mobile operating system. Now, types of operating system. Then we have the single user or personal user operating system. We have the single user or personal user operating system. Now, with a single user or personal user operating system, they are designed and developed to run on personal computers or personal machines. So your personal computer, if you're using Windows 10, you're using a single user operating system. So a single user or personal user operating system, and a very good example is a Windows operating system. Single user or personal user is designed to run on personal computers. So the ones that we use in our homes, the one that we use in office environments, all these are single user or personal user operating system. Now, with single user or personal user operating system, it means that one user using the operating system at a time. You can't have multiple people using the same operating system. It is only one user or one person using that operating system at a time. Now, for single user or personal user operating system, we have types. We have the single task and then a multitask. So when you take the single user or personal user operating system, it's a type of operating system. But when you go into the single user or personal user operating system, we have the single task and then we have the multi-task. Now, when you take the single task, it means that that operating system can allow you to perform one task at a time. You can't perform more than one task. So if it is making call, you can only finish making the call before you go ahead to watch a video on YouTube. That if you're using your mobile phone. If it is your computer, if you are watching a music video, you can only finish watching that music video before you go ahead to launch Microsoft Word and type. But if it is multitask, it means that you can do a lot of things or you can perform, execute a lot of tasks on your computer at the same time. So an example of a multitask operating system would be an example of a function that you can do as a multitask under the single user or personal user operating system is playing music and then typing on Microsoft Word at the same time. Or you playing a FIFA game where you mute the voice and then you play a music or audio at the same time. So you are able to do more than one task at the same time because you playing a game is a task, and then you listening to music is also another task. Or you listening to music is a task, and then you typing using Microsoft Word at the same time is also another task. So once you're able to do these two things at the same time, then what you're doing is multitask or multitasking. And then single task and multitask are under single user or personal user operating system. Now, multi-user operating system. Multi-user operating system means that there is an operating system and then you have a lot of people using that particular operating system. So operating system allows two or more users to efficiently use the computer's resources. That is multi-user. That is very different from single user. So single user, you have only one person using that operating system. But with multi-user, there is this one operating system, and then every user is connected to the operating system. And an operating system helps each user or all the users connected to it to efficiently use the computer's resources. So it shares the computer's resources among the users simultaneously. So simultaneously, if you want this particular software, the operating system will have a way to give that software to you. And then if I want that software too, the operating system should or has a way of giving that software to me. So it shares the computer's resources among the users that are connected to that operating system simultaneously. So that is multi-user operating system. Then you have network operating system. Now, network, anywhere you hear network operating system, know that there is a server. Now, a server is just a powerful computer with resources enough to be able to respond to a client's request. So let's say that you get onto YouTube and then you want a particular video on elective ICT. Now, when you type the name of the video, that is the video. When you type it and then you hit search, now once you do that, your request is sent to a server. The server will then listen to your request and respond to it by giving you the video you requested for. Now, the person who requested for the video is called a client and something that we look at under networking. And then the computer that responded to the request is called a server. Now, this server it needs an operating system. And then the type of operating system the server runs is called network operating system. Now, network operating systems are run on servers, and then they allow or they give the server the capability to manage users and data as well as security functions of that server. So that is network operating system. So they manage users, they manage data, they manage security policies of that server. And then an example of a network operating system is Windows Server 2008 or Windows Server 2012. However, you can use Unix and Linux as network operating systems. And then there is a novel netware and others. So all these are examples of network operating systems. Then batch operating system. Now, batch operating system. So anywhere you hear batch, you should know that it means that things are done in a group. So batch, so 2022 batch, it means that 2022 group. So batch operating system has everything to do with running similar jobs once. Running similar jobs once. So with batch operating system, you the user, you don't get to interact with the operating system. It says the operator. So the batch operating system has an operator where if you want something done, you just go to the operator and then you leave your job. The operator will gather all the jobs that are similar and then run on them once. This is done to make sure that the computer's resources are efficiently put are efficiently used, or they are put to good or proper use. So it doesn't run the similar jobs one at a time. No, it gathers all the jobs that are very similar and then runs them once. Finishes, go to a different job that is a different job that are similar, and then runs them once. So that is batch operating system where similar jobs are put together as one and computer resources are allocated to those jobs. That is batch operating system. Now there is a mobile operating system. So mobile operating systems are designed to run on mobile applications, like mobile phones, tablets, and then wearables. So they use the mobile operating system. Now, mobile operating system, an example is Android, another example is iOS, another example is Harmony. All these are mobile operating systems, and they are designed to run on tablets, our wearables, and then mobile phones. So if you don't know a watch is a wearable device. You can use a watch to make calls, you can use a watch to pay calls, you can use a watch to browse the internet or the web, and that makes it a wearable device. And then it runs on an operating system known as the mobile operating system. Now, process and their states. Process and their state. Now, you should know that when you run a program on your computer, let's say that you run Mavis Beacon or you launch Mavis Beacon to learn how to type. Once you run Mavis Beacon is a program until it is being run. So Mavis Beacon on your computer, as you see it on your desktop, is a program. Once you run Mavis Beacon or you launch it or you double click on Mavis Beacon for Mavis Beacon to open, it becomes a process. It becomes a process, and then you're going to look at process and their states. Now, a process in operating system is a program in execution. So, like I said, once you run Mavis Beacon as a process, Mavis Beacon as it is on your computer without you running it is a program. Once you double click on Mavis Beacon or you right click and then you choose open, once you do that, Mavis Beacon becomes a process. So a process is a program in execution, a program being worked on, or a program that has been assigned a CPU, a program that is functioning. So once you have that, it is called a process. Now, a process can be in one of several states in an operating system, depending on its current state of execution. So we are going to look at the state of a process. Now, a process can be new. This is the initial stage of a process when it is created by the operating system. So when you have Mavis Beacon, it's a program. Once you launch Mavis Beacon, now a process has been created and that process is new. So when a process is new, then it means that that process has been created by the operating system. Now, once the process is created, another state has to happen, or the process will move to a different state. Now, ready. So once the process is created, that is a process becomes new, a process can be ready. So in the ready state, the process is waiting to be allocated a CPU time for execution. Don't forget that anything you do on your computer needs the central processing unit, because the central processing unit is the brain of the computer. It processes all the information, very much like our human brains. So for something to be processed, that thing has to be given a CPU. So once you create a process, that process is new. And once that process becomes new, automatically it is ready to be assigned a CPU. So a process can be new, a process can be ready, a process can be running. So this is the third state, a process can be running. So in this state, it means that a process is being executed by the CPU, or the process has been assigned a CPU, because once a process is assigned a CPU, it will start working. So if the process is not assigned a CPU, it will be in a queue. It will be in a queue until it is assigned a CPU, then it will start working. So if you have a process running, that means that that process has been assigned a CPU and the process is running or working or being executed. Now, blocked, another state is blocked. So in other books or on the internet, you see on the web, you see blocked, suspended, or waiting. Yeah, the same thing. So it is either you have blocked, suspended, or waiting. So a process can be blocked, a process can be suspended, or a process can wait. Now, on that state, it means that a process couldn't finish executing before something happened. So if an event occurs, the process would have to wait, or would have to block, or would have to be suspended until that event is taken care of. So let's say that you were running again Mavis Beacon was running, and then you slot in a flash drive. Once you slot in a flash drive, that is a signal, okay, an interrupt signal. So once the interrupt signal occurs, Mavis Beacon will stop running. You won't see it, okay, you won't see it. I'm describing it as though it happens for you to see. No, you won't see it. But once you slot in a pen drive or a flash drive or anything, Mavis Beacon will stop running. If that was a current program, it will stop briefly. Then your operating system will listen to the device that you slotted. Now, after communicating with that device, it will then go back to assign the CPU to Mavis Beacon after it is done with the device that you slotted, before Mavis Beacon will continue to run. You won't see it because you slot in a flash drive and maybe it's Beacon stays. But for computers that have low resources, you see that if you're watching a video and then you slot in a flash drive or something, the video pauses for a while, like just for a second. In a split of a second, you see it pauses and then it continues playing. Yes, these things happen, but you won't see them because they happen so fast, so fast. So you won't see it. But yes, a process can be in a waiting state, a process can be blocked, or a process can be suspended. I said that they are the same thing. So if a process is blocked, suspended, or waiting, it means that it is waiting for some event to occur. And then again, for some of the processes to, they need an event to occur. They need an input from the user. They need an output resource to be able to finish the execution. So when you're printing something, for instance, it needs an output resource to be able to finish. So until it gets that output resource, it will be waiting or be blocked. That is, if another process is using or another user is using that same output resource. So some of the process needs a user input or output to be able to continue or finish its processing or its execution. So we should also note that. Then a process can be terminated. Once a process is done executing, it has to terminate. So once you have terminated, then it means that the process is done with execution. So these are the states of a process in an operating system. Now, so using this diagram, a process is new. It means that a process has been created, so it's new. Once a process is created and it's admitted, it goes to the ready state. So in the ready state, it will move to the running state where a CPU is assigned. So once a CPU is assigned, it moves to the running state by the scheduler dispatch to the running state for it to start being executed. Now, if the process is being executed, one of three things can happen. Now, a process can finish and then exit. So when it exits, it means that it has been terminated. That's the next state. Or a process can wait for input or output events. You get that? So once the process is needs that input or output or an interrupt or something happens, the process will then move to the waiting state. Now, the process again can be running, but an interrupt will occur when you slot in the flash drive, or even from the computer system itself, an interrupt can occur. So once the interrupt occurs, it goes back to the ready state. Now, if a process is running and it needs an input or output, it goes to the waiting state. Now, once it gets that event, it goes to the ready state. Then from the ready state, that same process will be assigned a CPU again, then it will go back to the running state. Now, once an interrupt occurs, it goes to the ready state. And once it's assigned a CPU or the interrupt is taken care of and it's assigned CPU, it moves to the running state. So if a process is running and there's nothing, like nothing happens to it, we just go to the exit, that's the terminated state, and then the process will terminate. But if the process needs an input or output or an event to continue, then it goes to the waiting state. Once that input, output, or event is completed, it goes to the ready state where it waits for the CPU to be assigned to it, then goes back to the running state. So this diagram just gives you a snapshot or a fair idea of how a process and of a process and then its states. Now, functions of operating system, processor management. So the operating system does process scheduling, where it decides which process needs the CPU, which process needs a CPU, and then for how much time, and that is known as process scheduling. So don't forget that we run a lot of applications on our computer, or we run a lot of programs. You can open a VLC media, you can open a web browser, you can open Microsoft Word, and then all these things need the CPU. Now, the CPU has to determine which one has the highest priority, and then gives the CPU to the one with the highest priority. Now, when the one with the highest priority is done running or done executing, then the next one will follow. So if it is able to determine the one with highest priority and then assign a CPU to the one with the highest priority, we say that it's doing process scheduling, where it decides which process needs the CPU and for how much time. Then it does another function, that is allocation and then deallocation of CPU. So once it allocates a CPU to a process and that process is done, it has to take that CPU from the process. So allocation and deallocation of a CPU. Now it does memory management too. Now in memory management, the operating system tracks memory, an empty space for a memory, and then a memory that contains data or instruction. Now, if it doesn't do this, let's say that there is this memory and then one space has instruction and then another space is free. If the operating system does not determine that, and then you want to run another program, the likelihood of that program overriding the existing one is high. But because the operating system does memory management, it will say that, oh, okay, this particular slot has been occupied, so move to the next available empty slot. Then the next available empty slot will take the new instruction or the program that you want to run. Now, in memory management again, once instructions are done running and they are out of memory, the operating system takes that memory and then give it to another process or another program. So again, it also does allocation and then deallocation of memory. It also decides the process or a program that needs memory and then for how much time. It does file management, yeah. So our files that you have on your computers, files that we created using Microsoft Word, or our video files, or our picture files, and those things. It does file management by allowing us to put passwords or choose the users that we want them to access the files. It allows us to hide the files. It allows us to delete the files. It allows us to move the files. So if you're able to do all these things, then the operating system is doing file management. Then there is device management. So device management, it also manages our devices that so it can be a flash drive, a hard disk, or the external hard disk, or the internal one. So it helps us in device management by being able to also again put in security measures on our device, also determine users that can access our device, also helps in the efficient running of the device, and also determines the program or the process that can get a device and then for how much long. After a device is assigned to a process and it is done, it takes the device away from that process. So it is allocation of a device and then deallocation of a device. Then user interface. In our definition, we saw that it acts as an interface between the user and then the computer hardware. So user interface, where it allows us to access files on our computers. It allows us to read stuff, use the computer efficiently, because without operating system, we cannot be able to use our computer. So it does, or it helps in user interface. And there is also security, where you are able to put a password or a PIN on your computer There is also communication. It helps communication. There is also job accounting. All these are functions of the operating system. Now you have to check the description of the video. I'll put the individual functions there, the processor management, the individual function, the memory management, file management, and then device management. So do well to check the description of the video. All right, all too soon, we've come to the end of today's lesson. Try the hands on the following. So define the following: process, operating system, system software, and then device drivers, not device drivers. List and explain the state of a process. State and explain the functions of operating system, and then state 4 uses of utility software. Now, thanks for watching. Next tutorials will be on application software. Subscribe and keep the channel active. Do not forget to tell another person that Anti-Dote series is here. And I'm very grateful for the subscribers and the emails that keep coming. And I believe that I'm keeping up, doing my best, replying to all the emails that I have received and I keep receiving. And please do reach out where you are lost. Don't worry. I'm here to help. Thank you very much. Until we meet again, it's bye for now.